15. How about structure one? Three as a test if you like. Yeah, structure one, have you done any?
No, structure one didn't do lecture, the objective I did.
Okay, I think I'll give you about 10 minutes to do the structure one, 1 to 5. Try all this.
Okay.
1 to 15. Multiple choice, 1 to 5 structure, and then you've got 10 essay. Okay, if you want a formula, you can use this as a guide.
Yeah, no, just proceed like this.
You can work on it. They give you a chance to work on it, and then after that, you'll go away rather than I go away, and then you don't understand what's happening.
No. I think this is wasting time, lecture. Now you just do lecture first.
No. You have better do first. It's a waste of time if I teach you. You don't learn anything. 10 minutes.
Yeah.
10 minutes, then we'll carry on. Okay, shall we? Or you want more time? Okay, what's the answer for number 1? Yeah, Srini? What's the answer for number 1? A particle performs simple harmonic motion and its displacement from a fixed point O at a time t is y. The acceleration of the particle is given. Which statement about the motion of the particle is correct? Okay, what's the answer?
A.
Okay, A is a constant. Acceleration is always negative. That doesn't tell anything, right? It has to say it's always opposite to displacement. Velocity is directly proportional to y naught. It's an ellipse. Period of motion depends on y. Does it depend on y? False. Right? Y is the displacement. Period depends on k. Okay. Number 2. I think we have done this already, isn't it? Where did we stop? Can you remember?
Number 2 is B.
Okay, I think we have done this already. So we won't spend too much time. Go to the formula. And then omega is 2 pi over t. And replace your time here, inside here. 2 pi and 2 pi cancel off. So this inverted. Then your V naught is A omega. A, this is omega. Answer is B, okay? Number 3, I don't think we will bother. Okay, number 3, okay? What's the answer?
Boy.
Okay, I told that a light platform is supported by 2 identical springs. A mesh is placed at the center of the platform so that the springs are compressed. That's your platform. Press the mesh here, it compressed by 3 cm. The platform is depressed further by 1 cm and then released so that it oscillates up and down vertically. Which of the graph shows the variation, the displacement of the platform in time t. Okay, you depress it. This is the rest position. When you put a mesh there, when you depress it, you are going to maximum first. Depress at 1 cm. So, okay, answer is B, correct. Okay, when the mesh is placed on a platform, it come to a new rest position. Amplitude is 1 cm. Okay, how about this one? An object of mass 2 kg undergoes simple harmonic motion according to the equation where x is the displacement in meters, t is the time in second. What is the frequency and kinetic energy of the object when the displacement is 3 meters? Yep. How do I solve this question? What is the answer?
A.
How do you find the frequency? Yeah. How do you find the frequency?
2 pi f equals to 100.
Okay, good. Go to this equation. Amplitude is 5, omega is 100. So F is omega over 2 pi, calculate out. Then how do you calculate the kinetic energy? Right? You can calculate the total energy. This is the total energy. Right? I use the potential energy formula. So calculate the kinetic energy. E minus U. So this is the total energy. This is the potential energy. And put in your value. Mass is 2 kilogram. Omega, we have got that 100 square. A is 5 meter. Displacement is 3. Okay, A, good. How about this one?
Donkey.
Donkey. Actually, it's also poorly done, this one. It should be good towards a lower frequency, correct? But it should be below here. Okay, that's the best anyway. Okay. Sorry. Cannot be donkey. It should be A. A. Unless it's over them, then it will shift towards this side. If not, they are almost the same. Frequency almost the same. Okay. Okay, let's go to number 6. Variation of displacement x with time t for simple pendulum is shown in the graph below. Which equation expresses the above motion? Okay. What's the answer? Got different method of doing it. Yep. What's the answer?
Boy.
Right. Can either use this cost graph. Amplitude, you should be able to read. Amplitude is just 4. And then the period is from here to here, 0. From maximum to maximum, or minimum to minimum, is 0.4 seconds. Then can calculate your period. Calculate your omega, 2 pi over t, 2 pi over 0.4, you get 15.7. Then you get this cos minus cos equation. Then the next part is just play with it. minus pi. That's your mass. And the answer is B. Okay, good. Right, where we use that trigonometric expansion. A minus pi is minus cos A. Okay. An oscillatory system. Another way is to use a sine graph lah. Right? Another way is to use a sine graph, and then it's shifted by pi. Sine graph there, shifted by pi. Then after that you can simplify. You can simplify, right? Use a sine graph, and then it's shifted by the part there, shifted by pi over 2. Okay, number 7. An oscillatory system is made to be critically damped to tune the frequency of the oscillation. Okay, that's not the reason. Stop the motion in the shortest time. What's the answer? Maintain the amplitude of the oscillation. Prevent the loss of energy of the system.
Boy.
Why? Okay. We want to stop it in the shortest possible time. Okay, number 8 is what? A pendulum of mass M and length L oscillate between A, B as shown in the figure. Which statement is true of the system if the air resistance is negligible? Yep. What's the answer?
Donkey.
Let's see. Let's go one by one. Kinetic of the mass is maximum at B. No, it should be 0 at B. It's maximum at O. Total energy of the system is maximum at P. Total energy is not maximum, it's always constant. The gravitational potential energy of the system is minimum at A. No, at A and B should be maximum. So you're right, donkey. The rate of change in momentum of the pendulum is maximum at A and B. Force equals to rate of change in momentum. Force is maximum at A and B. Right? This is where if we use acceleration equals to A equals to minus omega x. So at the A and B, the force is largest. Good. Donkey. How about number 9? The graph shows the variation of acceleration with displacement x of the particle performing simple harmonic motion. Frequency of oscillation of the simple harmonic motion is? How do I find frequency?
Omega equals to 2 pi f.
So how to find the f?
Oh, maximum acceleration is 0.6. So omega square x initial is 0.02. So substitute lah.
Okay, go to that formula. Know how to read your maximum acceleration. Amplitude. Right? Amplitude is here. Maximum acceleration is there. Then go to this equation. Find your omega. Right? From bottom of negative sign because we want the frequency only. Positive answer. So take the x down and then square root it. Put in your value. 0.6, 0.02. And calculate out. And frequency is omega over 2 pi. Put in your value and calculate. Okay. Answer is A. Any problem? If not, let's go to number 10. Which of the following statement about an object which performs simple harmonic motion is true? What's the answer?
Boy.
Okay. Acceleration is maximum when the velocity is maximum. Cannot be. Right? If the acceleration is maximum, velocity is maximum, the velocity can be maximum. It will still increase the velocity. Acceleration is maximum when the displacement is maximum. Okay. Right? But they are always in different direction. Maximum potential energy is greater than maximum kinetic, cannot be. They are always the same. False. Answer is probably correct. Okay. How about 11? The equation of motion of an object performing simple harmonic motion is given by that, where x is the displacement in meters, t is the time in second. When t is 1 second, what is the speed of the object? How do I solve this one?
Differentiate it.
Okay. Differentiate it. Right, there's your 5 there. Differentiate this sine, you get cosine. Differentiate your 5 or 6, you get that. And
So and they substitute t equals to 1, then get the answer.
yeah, substitute t equals to 1. Remember, it's in radian. The answer is A. Good. Number 12. The graph shows the variation of displacement x with time t produced by the oscillation of simple pendulum. Which statement is true? Yep. Which statement is true?
C.
C. Okay, let's see. Which statement is true? Velocity at 6 seconds is 0. 6 seconds is here. When you want to find the velocity, you take the gradient. At 6 seconds, here, sorry, 6 seconds is the maximum, so false. And the period of oscillation is 6 seconds. No, period is that's where you start. Look at the 2 peak there, is 8 seconds, so wrong. Acceleration at 4 seconds is maximum. Remember, the two are always opposed to each other. So when it is minimum, it is maximum. So you are right. True, acceleration and displacement are 180 degrees out of phase. Kinetic energy at 2 seconds is minimum. 2 seconds is here, velocity is largest, so it cannot be minimum. Okay, so you're right. Answer is C. 13. Displacement of a particle moving in simple harmonic motion is given by x equals to 5 sine 2t, where x is in centimeter and t is the time in second. If the period of motion is t, the acceleration of the particle at... Okay, this looks a bit challenging. How to solve it?
X equals to 5 sine 2d, omega equals to 2 equals to 2t.
Okay, omega equals to 2, correct? From omega, I can calculate your period. 2 pi over 2 is your t. Then your velocity is dx dt. Differentiate the equation. So it's 5 times 2 cos omega t. And differentiate again to get your acceleration. Minus, this is 10. Differentiate cos, you get negative sine. Then there's a differentiate this one, you get 2. Then put in your 20. Put in your, there's a 2 there. Now time is just your 3.14 divided by 6. Okay. A. Any comment? You are right. How about number 14? Object of mass M is in simple harmonic motion of amplitude A and angular frequency omega. What is the maximum restoring force on the object? Okay, what's the answer? Yep. What's the answer? Just find the acceleration. Right? Acceleration formula minus omega square A. Then the restoring force is just your Newton's second law. F equals ma. Okay, the answer is B. Okay. Number 15. Which statement about simple harmonic motion is not true? Right, which one is the incorrect one, not true? Yep, what's the answer? Make sure after your class, take a short nap before you come for class. Then you are refreshed.
C.
Okay. A is true. Amplitude of the oscillation is constant, true. No energy is lost. Speed is maximum at the amplitude, no. Speed is 0 at the maximum displacement, so false. Acceleration is 0 at the mean position, correct. C, correct. Okay, how about this one? The particle is in simple harmonic motion of amplitude A and period T. What is the time taken for the particle to move from plus A to x equals to A2? Yep. Yep. What is the answer? Any idea how to calculate? Right, from A to 0, is 1/4 T. So from A to half A is smaller. Right? If you want to reason it out, then you will get the answer as A, smaller than half, smaller than a quarter, sorry. Right? A to 0 is a quarter T period. So from A to half A is going to be less than a quarter. So you can choose A or calculate up properly. Right? You start with A maximum. So you use a cos graph. You use a sine graph, you have to calculate twice. So one is where x equals to A, one is where x equals to that. Then put in your whatever is given, your period is t, that's 2 pi omega over t. So put your A as A over 2. Then calculate your t. Okay. A over 2, A and A cancel. Half is pi over 3 equals to that. The answer, that's the answer. Okay. We'll take 5 minutes break. Since you haven't done the structure, you can use the time to either have a drink and then solve the problem.
Okay.